Hey there folks, welcome back to another part of my thing where I am making a Tetris data extractor. So last time we were refactoring, we had some fun, but we stopped short before we actually were able to run the program and see our changes actually work. So that's what we're going to do today, hopefully. We'll just carry on with refactoring. So I want to finish getting the app settings fixed up, and we're going to have to find precise areas of a screenshot to actually put into our new configuration format by providing the entire rectangle instead of just a top left XY coordinate. And then we'll run our tests. We'll see how it works. And then I'd like to do some refactoring of the actual algorithm itself. There's a few more things I can do to make it a bit more efficient. And let's just say there's a lot of file I/O going on in that algorithm. And it does not need to be. We're constantly loading up and reading files. But we'll talk about that when we get there. For now, let's get what we have set up running all good. Okay, so we have our XY coordinates, we have our widths, and we need a height. And we really don't know what these are. So we're gonna actually just open some screenshots up in GIMP and try and figure it out. I know we already did this before. When we were first doing our algorithm, where am I going? I can't think and talk at the same time. Let's just open up this. Because these should all, yeah, they're all perfect. Perfectly placed here. Okay, so we don't actually want to open that up. Do we have GIMP? We do have GIMP, so let's open it up in GIMP. We're going to find the bounding box for everything. And we're going to make sure that it's divisible by a certain specific the number of digits. So let's look at the lines first. We'll get in here and we will do this. Now this box is 65. So I think I probably want to make it 66 by 22. Looks pretty good. So this is a 66 by 22 box. So there should be 66 by 22. Does that mean a 22 by 22 box? Let's have a look. There's a 22 by 22 box. Oh, that's pretty nice. Interesting. Okay. Well, that makes things easier. 22 by 22 for my screenshot anyway. This pixel up here is 423.47. So let's open up here, get my lines. .423. Oh, that's the level. Whoops. Oh, look at this. 423, right, 47. So we're going to say this is 22 pixels for each character, and the height is going to be 22. They're all going to be 22. So really, why are we actually... Well, last time I think I said I'm going to specify height individually so we can change them. Let's just keep it simple. Yeah, we'll specifying them for each one is the simple simple way, because this is these are the actual properties of a rectangle that you can pass into the constructor. So this will be populated automatically for us. So, okay, let's look at the score. Right now our score is showing at 527, 146. Right there. So 6 times 22 is 132. That's the box I would do. It looks okay. I think what I would rather do is have it there. I don't know. Yeah, it's pretty good. That's quite moved over. So let's move this. Can I just move that by, oh, I can use the arrow keys. Look at that. It's just, whoa. Oh, I can move. Hold on. No, I want 132. Come on. 132 by 22. Now I can place this. Looks way too big, doesn't it? Let's make a 32 by 32 box again. I actually can do this. I can go fixed here. You probably can't see that. Size 22 by 22. No. 22. Fixed size. What is going on? Oh, right here, 22. No, 22 by 22. Okay, here we go. That's a bit too big, isn't it? So already this bounds this nicely. Does it actually bound these nicely? I mean, I think just barely. I mean, yes. Kind of does still. Let's go in here. And what's this pixel? 528, 145. Okay, 528, 145. The width is 132 and the height is 22. We're just gonna assume the measurements I took in previous times were semi-good as well. Like, I think, yeah, I think we'll be okay. Okay, level, let's get the level here. Armed with my new 22 by 22 by 22 box. Let's go into here. That looks good. A bit too much on the bottom, but that's actually all right. What pixel is this? 568, 399. No, hold on. 569, 399. And the width is 2 characters. The height is again 22. Okay, so now we got all the piece counts. And hopefully we only need to do this. Yeah. So the piece counts are going to be hard because of all of this junk here, they bleed into each other. My capture card is not the greatest. So there we go, I think. I think that's as good as we're gonna get. So 150, 223. This is the T, yeah. What was that? 150, 223. 150, 223. Now the width is 3 of them, and the height is 22. Come on. So I'm assuming the same one. 150, this is 223 now. Oh, shoot, I moved the whole, no, I was moving the whole picture. It's not what I wanted. Yeah, 263. No, 262. Doesn't really matter. $262. 150, 262. 262. I think what we're gonna do is I'm gonna change all of these to 150. And these will all get decreased by 1. And then we'll just check the last one to make sure that it makes sense. 150 and 457. It's like down 1 pixel, but yeah, that's pretty good. This is the super tough one. That long bar bleeds into that O, making purple pixels. Oh well. Our algorithm's just gonna have to figure it out. I wonder for the red ones, we're just gonna have to extract out all the non-redness or intensify the redness or something. But that's good. That's what we got there. These are all 96. Actually, I can just do this. Okay, so those are our screen positions. And that's good. Now, what I want to do as well, what I have to do is I have to copy this into our testing settings as well. Since they're separate from the main settings, but for now they'll have the same information. Yeah. Anyway, let's take a look at the program here and we'll run this. I just want to make sure our rectangles are being properly populated. So we have our data model factory, their screen positions, and there we go. X, Y, width, and height. Okay. So that's decent. All right then. Well, should we run the tests? let's run the tests and see what happens. So here we go. Now I should say before, the thing that caused me to write these tests in the first place was we refactored and everything broke. So we went back in time and we wrote tests and they all kind of passed. But then I merged them into the refactor, which apparently broke everything. That's not supposed to fail. I may have, remember this is supposed to just generate a report. It's not actually supposed to fail. What's the problem here? Argument parameter must be positive and less than height. What? That is very curious. Okay. Well, I don't know what's going on. Let's debug this and see what's happening. So which file are we doing? Yeah, we're doing 100. So let's pull that up. Discard all those changes. Let's open up 100. This is the file that we're looking at, as always. Unfortunately, I can't keep that on screen without this being maximized, but we will go forwards. So let's pull this down. We can see what we're doing. Okay, we're going to create the data. Now we're going to go in. We're doing lines. So we'll pass by all this. Expected equals actual. Interesting. So the lines worked out. Actually, I'll just pass over here. And because we've lazy loaded everything, it's actually got to run and generate and run code just for us to see these numbers. Oh, gross. Everything is awful. Look at that. 774. Like, we totally borked this. It can't even get the level. It has no idea what to do with that. The line's a 0, that's fine. That is so weird. Okay, well that's fine. Well, I mean, I expected to have a huge whack load of issues. We went from something that almost sort of kind of worked to something that doesn't work at all, which is fine. Let's actually have a look at, oh here, not score. Right, this was actually pointed out to me a couple of parts ago, so let's change that label. Oh man, now I can't even remember. What's our issue? I want to look at a white number first, because those are easier to deal with. Okay. It takes so long because it's got to load up and run the code just to display the number. So, okay, lines is fine. Level is kind of doing something funky. Let's look at score. Is score 222? Absolutely not. It's actually 0. Like, this is the... Okay, so let's look at score. So what we're going to do is we're going to go into score. And we're going to put a breakpoint here. The first time Oh, look at this. See, that's perfect, because I said, I already see this issue. I said that the score is only 3 digits. It's 6. But check out what happens in here. That 3 is used to calculate. So it's taking the whole 132 wide box and dividing it into only 3 parts instead of 6. And then it's forcing one of those big wide rectangles to be 2. Let's just demonstrate what I mean. Maybe? No. Anyway, our 132 box should be broken up into 6 pieces, not 3, which is why the score isn't working. Probably, hopefully, oops, maybe. No. So let's right away make that a 6. That was an error I did a while ago. Let's make sure everything else, the level, is that 3 digits? No, it's only 2 digits. So what is going on there? The lines are 3 digits. Everything else should be 3 digits, which is probably why I was just in a copy-paste mentality here. That's fine. Okay. That's fine. I think I'm going to go down here. And we're just going to do the first one. X starts with 100 PNG. So we'll only run, oops, the test for the one screenshot, which we've seen before, but now we're running against our Borked algorithm. So it is new. Okay, we'll debug this. See, we put a breakpoint when it's supposed to calculate the score, but it hasn't hit the breakpoint yet. So let's continue because it's lazy loaded. It's supposed to be lazy loaded. Hey, didn't I? It ran it. Where's my report? Score expected 0 but found 10. Okay. Yeah, so everything's broken still. That's fine. I guess I lost my breakpoint here. Okay, let's debug it again. But at least it runs now. Okay, so here we go. Let's just make sure my positioning makes sense. 528 by 145. Width is 132, the height is 22. So that makes sense. Let's go into here. The subimage is the bounding box. Okay, let's just do our thing where we make sure that everything is looking pretty good. I will save this. And we'll have to go into, where are we here? Tests. Bin, this one. There's our test. That's what it's grabbing. It's sort of all right, but not quite. That's not very good. I thought there's a lot more space to the right. then to the left. Okay, let's see what happens. So number of digits is 6. Character width is 22. The character height is going to be 22 as well. Let's put a breakpoint here and look at this digit image. Oh, come on. Digit image dot save. And that's fine. So that's being figured out to be 0, which is okay. Let's actually put a breakpoint here and see how this digit is 0. That's right. Digit is 0. That's right. The 4th digit is read as a 0. That's right. The 5th one is read as a 1, though. So let's get this open and see why this is being seen as a 1. Because we're just moving over. We have a one-off pixel issue here. I'm not sure what the issue is. Because this is the 5th one, and it's just 1, 2, 3, 4, 5. I've got a one-off pixel thing here. I'm going to say a width of an... There's only 21. Interesting. So if the width of a character is 21 instead of 22, that's going to change all of my widths here. Which kind of makes sense. I had too much on the right-hand side. So we're going to take off 1 for the number of digits. So the score is 6. So we're going to take off 6. The level is 3. Wait a second. Because now I want 21 by 6. That's fine. My level was 2. Oh boy, see this width. I was thinking 32, not 22. So not only, oh yeah. And then everything else was 32. See here, I was thinking 22 in my head, and then it automatically, yeah, us computer science nerds, the number 32 is a much more natural number to think about than 22. But now I want to make it 21, so now we're going to have to redo all of this. So the level is 2 characters times 21 is 42. Whoops. Lines is 3, so that's 63. These are 4. 4 times 21 is 84, not 96. Oops, 84. 84, 84, 84, 84, 84. Okay, and the heights are still 22. Okay, so this is now based on a 21 by 22 character height. Okay, let's, so it makes sense that everything was bonked because I had all of my settings wrong. So let's debug this. And let's see what I get. Got some weird stuff going on here. Oh, I see, because I think because I had a breakpoint in the algorithm, and to show it, it had to run the algorithm. So I don't even know what's this report. Is it still showing weird stuff? But now look, I've got all the piece counts. So all the score is right. Okay, let's take a look at all my breakpoints and remove them. That's what I want to do. Breakpoint here. Let's debug this one more time. Okay, and have a look at all my pieces of data. So I've got score, lines, level. Level's actually supposed to be 1. I don't understand. Score is 0, lines is 0, level is 0. I'm so confused right now. And the reason I'm confused is because in the debugger, did I delete it? Oh. Where's my text? Oh my word. Nope. Well, my report shows that the score, level, and lines are fine. Oh, see, there. That was me deleting it. Or my natural tendency is to close the file. Okay, so that's okay. Okay, so let's figure out all the red stuff. So make sure I don't have any breakpoints. Let's look at the T number. Now the T number is being, I'm going to pin this. The T number is being found to be 772, which is ridiculous. So let's put a breakpoint here. This I want to pin as well. Okay, here we go. Debug. Make sure this positioning looks okay. No, the positioning looks terrible. Look at this. Why did I say it was 84? Oh, but see, I keep putting in the wrong number into my app settings here. These are not 4 characters long. These are 3. So again, that's why it was totally conking out there. All right, let's try this again. We'll just run it. We'll run it instead of debugging it. It'll run through to completion, and we'll have a look at the Look at that, you guys. The data recognition report is empty. Okay, let's, so that's exciting. Okay, so now let's run the tests again. And this time, let's have a look at the report. We can see it grow. What? There we go. Oh, of course, because we didn't. I was thinking, boy, we're not seeing any issues. But I only write the file at the very end when we're ending the test, so that makes sense. Okay, these look familiar. No, they don't. They look different. I'm mistaking 4s for 3s. No, I'm mistaking, yeah, 4s for 3s. 3s for 8s. But again, only S, J, Zs, Ts. Every single O piece worked. Is there something special about the O piece? No, not that I know of. Okay. Well, we have a few things to fix. That's it. So the 102, let's go back there. 102, the S was supposed to be 3. No, it's supposed to be 4, but we found 3 here. Okay, let's see what's happened. The other thing I should point out is that we are taking about a 1 second to, over 1 second, to figure all these things out. And that's not great. So hopefully we can make that faster. But let's get things working first. So, let's get rid of our breakpoints. We're looking at 102 now. Okay. And we'll put a breakpoint in our S. Okay, and we'll debug our test again. So my goal is that we can actually get the data from a screenshot in its entirety in way under a second. But efficiency will have to come later. Okay, S piece, this is what we're after. Everything looks fine. So let's go into here. Now this is being mistaken for 3. So let's take a look at the sub image. Let's clear this here. The sub image. Here, let's actually evaluate the sub image first. Let's save test. G. Enter. Good. All right, we'll go back. Actually, let's open up a new window here. Test. So this is what we're looking at. It looks pretty good. Now I can't fault my algorithm for not being able to recognize this. How blurry and gross is that? If this were an emulator, this would be so crisp and clear. It would be as easy as the white numbers. All right, so the first two I think it's going to find is going to be zeros. The digit found was a 0. The second digit found was a 0. And now this one, is being mistaken as a 3. Let's have a look at it. The bounding box is very nice. Like, it makes sense to me. Okay, let's go into here and see what is happening. So we're going to reduce the image, and this is the problem. When we reduce the image, we remove all the black pixels around it. But so we lose so many things. Like, that is hardly recognizable as a 4. I'm curious what the probabilities are. If we find all the probabilities for this. So the probability that it's a 4 is 88, and the probability that it's a 3 is a 100. Yeah. But if we take a look at the actual bitmap, before it was reduced, you can see there are some things sticking out here, but this whole thing is just being chopped off. You kind of tell why it would be a 3, eh? Because you have this, but you're just missing the tail. Crap. This is frustrating. Okay. Well, we're going to tweak. I mean, again, our options are to move the box, but I think we got the box position figured out. The only thing left is what determines a black pixel. So let's just figure that out. Actually, I wonder if I can... We'll try a few manual techniques here, but we might actually have to write a program to figure out the best value, I think. No, I need my color checker. We're at 150. Let's allow more to be black. So I'm going to put a comment here saying original works with all white numbers was 150. There we go. So now I'm going to manipulate this to my heart's content. And I will run this again. So this was the report before. Let's see what happens when we allow for more pixels to be kept after. Okay, so by allowing more pixels into the picture to be kept, allowing more pixels to be considered not black, gives us a better representation of the number. Now, that was only that one screenshot though. So let's run all the screenshots. Let's do this so we can easily get that back. Okay, let's run everything again. Here we go. So we'll run it all, and run. There we go. I'm still expecting all the white numbers to work. I'm expecting different red numbers to fail though, unfortunately. But hey, what do I know? Wow. That is good. That is super interesting. So in only 2 cases did we make errors. Everything else worked out. Wow. Okay, let's look at these screenshots. I want to look at 105. The S. Expected 12, but found 17. That, I think we had an issue with before. Okay, and then in 113, we expected 32, but we found 82. Again, I can't fault it for that. Look at that terrible 3. And are you telling me, like 114, and here's what I don't understand. So this is 114. It found the right value, but 113 it did not. Like, look at that. Oh man. And check it out. Here I was on level 6. And here I'm on level 7. Does the color change any of that? My word. That would be absolutely nuts if it did. Can I keep this? No. Okay, so let's drill into these 2 cases. Wow, I'm impressed. I'm very impressed. Okay. All we did was change that to 140. Okay. And I think we're gonna actually, you know what, I think we are going to allow this value to be configurable. We'll do that after we look into this though, because there's got to be some power on the user's end to change that value as they see fit. Okay, so we're gonna run 105. And again, it's only the S's, which is bizarre. That's a really strange one to me. I'm not sure what's happening at that specific position of the screen. Okay, we'll go into here. So this is being read as 30. I can't remember. It's just being read as 17, but we're finding 12. No, we expect 12. We found 17. Gosh, where did I go here? Digit reader. Oh. Where am I? Here we go. And again, this is not going to be that different than everything else. Nope. How can that be? Okay. We are correctly finding this digit as a 0. The next digit is a 1. Okay, I want to look at this supposed 7 here. Oops, I called it Panog. Ooh. There we go. There'll be a Panog now. There it is. A Panog file. Delete that. This is my supposed 7. Come on, you cannot get any better than that. This is not a bounding box issue. Let's see what my probability list is. Well, let's reduce it first. What does it look like after it's been reduced? Oh. Reduced image, oops, capital S. Okay, and that's why it's just ever so slightly. So I'm losing too much of it. I feel very much like deja vu here. I'm experiencing deja vu. Several videos ago when, you know, before we merged this back into our algorithm, our refactored algorithm, I can see why that's a 7. The problem is I'm losing too many pixels along the bottom of the 2 that it's not really working out, and so my probability list Probability that it's a 7 is 86. The probability that it's a 2 is 84. So they're almost identical. It's just not quite there. And so I think what is going to happen. Now, I can play with the black pixel level one more time. Maybe 145 is the sweet spot. But the problem I'm seeing in multiple cases is that sometimes two numbers are almost the same probability. And I think when we have a near tie, like this one is a pretty much a near tie, I think we're going to have to maybe have a separate algorithm to differentiate ties. That's too much work. I don't want to do another separate algorithm. Okay, well, let's do this. 140 was almost perfect. So let's bump this up to 5. You know, maybe things will be okay. We'll run it for 105. We still found 17. So let's oh no. Yeah, because we want to allow more pixels to be non-black. So 45 wasn't good. What about 48? Like this is so tricky here. .148 works for screenshot 105. What was it? I can't remember what the other was. It 112? I don't know. We'll just run all of our tests. But I'm not very impressed with what's going on here. If the difference between 145 and 148, that's pretty outrageous. So one thing we could do, for instance, is this is pretty Tetris agnostic right now. We're just looking at numbers. But if we understand that we're in the context of a Tetris game and we knew what the piece count was last frame, and we get something that's drastically different this frame, we have two possibilities, you know. Last frame there was, you know, 11 O pieces or S pieces, and this frame there's 72 or 17 S pieces. That doesn't make sense. So then we could eliminate the 17 from contention because that's kind of physically impossible. That would require adding Tetris knowledge to this program, which I was hoping not to do. We'll do that only as an extreme last resort. I think one of the great things, and I keep saying this again and again and again, is that the piece counts are the least important pieces of data. It's the lines, the score, and the level is what you really, really want. So anyway, let's, did I run it? Did I run it? Now I can't even remember. Run. No, I don't think I ran it. Okay. And if you recall, a few sessions ago, I did play a whole bunch of Tetris. I have like 70 other screenshots to add to this mess because I really want to make sure it works. Okay, so we ran them all. Yeah, so we get more errors by bumping it up to 148. So not good. Not good. I gotta bump it back down to 145. So silly red numbers. Oh, so silly. I'm trying to think what I should do. You know what I need to do? Is I need to be able... See, here's a thought. All I have is the threshold. 1 second. Whoa, you guys, I think I just lost my face. I think my phone just died. So I'm just talking through the mic on my laptop right now. But I wonder if there's a way to take a certain threshold of brightness of a pixel and to increase it. Some kind of exponential function that says the distance you are from the threshold increase your saturation so that bright pixels get exceptionally brighter and dark pixels get exceptionally darker. I don't know, I feel kind of out of sorts not recording with my nice audio or my face on screen. So I think what I'm going to do is turn this back into 145. Oh no, 140 was almost perfect. Oh, what? No, I can't remember. We'll just run this. Run the tests again. The other thing I could do is force a 1 or 2 pixel border. That reducing will always remove a 1 or 2 pixel border from the left and the right and the top and the bottom. That way any bleed over from another digit to the left or to the right is eliminated. That's another idea as well. Okay, so 140 gives me only these two issues, which is just almost perfect. Okay, we're going to stop it there because, yeah, everything's dead, and you're listening to a very crappy audio of me and my computer screen. So next time, I don't know what we'll do next time. We're gonna figure this out though. Yeah, I'll have to do some thinking about it. But anyway, thanks for joining me. Have a good day, and we'll see you next time.